Okay, Assalamualaikum everyone. Okay, so this is actually the first session for KFS 2113 Engineering Mathematics 3. Okay, so you have reviewed the course informations, okay, in the previous video. So for now, I'm going to explain a bit regarding the first course outcomes. Okay, so as you can see on the whiteboard here, the one that I have written on the whiteboard is all methods, basic methods required for the first chapter, okay, in the first course outcomes. Okay, so several methods that you will learn in the first course outcomes. Okay, start with the Gauss elimination. Here, Gauss eliminations involve elementary row operation, okay, or we can call it as ERO. So this ERO you have learned basically in Engineering Mathematics 1, okay. But in this chapter, you will see more detail, okay. You will see in depth. There is some extension in the ERO or special ERO that required, okay. And then after this Gauss elimination, we will see also the Gauss Jordan. Okay, so in the Gauss Jordan, inside the method there is a ERO. Okay, only this Gauss Jordan is a continual process after Gauss elimination. Okay, so then we have LU decomposition. Okay, L means lower, U means upper. So in this method, okay, there are different types of LU decomposition. The first one is basic LU decomposition. Okay, sometimes we have a different problem that required using pivoting. Okay, either it is common pivoting or partial pivoting, or it can be scale partial pivoting. Okay, so this part will be a unique one. Okay, and then we have the next two using Jacobi and Gauss-Seidel. So these Jacobi and Gauss-Seidels are basically methods in numerical one, or we call based on iterative method. Okay, so these two are iterative. So when we call iterative means that you have the formations and then you need to conduct the calculations for a certain number of iteration. Okay, so that's why these two methods are called as iterative methods. Okay, so all methods involved in this chapter, okay, the problems will be based on solving simultaneous linear equation. Okay, so it is a linear equation, but when we call it simultaneous linear equation means that we have more than one variables that required to solve. Okay, so the number of variables involved in the linear equation will be depending on the total number of equations. So if we have three variables given, so in order to solve the problem or to solve the equation, you must have at least three equations. Okay, it cannot be less than. So same goes if we have, let's say, four variables such as A, B, C, D. Okay, so find the solution for A, B, C, D. So you must have at least four equations to solve. Okay, so in this subject actually in mathematics 3, all methods that you have learned in this chapter will be based on numerical methods. Okay, but you can compare with the one that you have learned in previous subject in Engineering Mathematics 1.